Today I'm teaching you the transient analysis based. This is lecture 7 and lecture 8, transient behavior of RL circuit and transient behavior of RC circuit, and your assignment, that is assignment number 3, right? So based on this, so you need to know the basic things first. Okay, so what are the basic things? That there are basically two types of response, as I told you earlier also. What are those response? One of the response is the transient response and another response is the steady state response. Okay, like if you are at the same position from a very long time, means you are sleeping, and from the very long time you are sleeping, that means your position is same, right? So that is the condition of steady state, means that is switch की position is same from a very long time, तो वो कौन सी condition हो जाती है? Steady state. Okay, but if the switch position changes, okay, like suppose if you are moving, and if you are moving, so your position keeps on changing, right? तुम चल रहे हो and your position keeps on changing. So if switch की position is changing, then in that case that condition is known as transient condition. Got it? Like for example, I'm taking a simple condition, like this is the switch, okay, and this is RL based circuit, and they have marked the arrow like this, and they have mentioned it over here, this is at t equal to 0. So according to the arrow, there are three things. One is the condition for t equal to 0, another condition for t equal to 0 minus, another condition for t equal to infinity. Okay, so what does it show? Ki at t equal to 0, see the arrow, at t equal to 0, the switch is closed or opened? Tell me. Hmm? At t equal to 0, the switch is closed or opened, correct? So what we can write down? T equal to 0, the switch is closed. Okay, that means just before that switch was opened, right? And at t equal to infinity, like at a very after long time, the switch will remain closed only, correct? So in this particular condition, at t equal to 0, the switch is closed. At t equal to 0, this is the condition of transient, because here the switch is changing its position, right? And at t equal to 0 minus, just before the close, that is the condition of steady state, because switch was open from a very long time, like suppose you enter the room at 8 p.m. okay, so 8 p.m. you switch off the close the switch, that is transient. And before that, from a morning to evening, switch was opened, so that is the condition of steady state, means switch is not changing its position. And at t equal to infinity, like around 12 p.m., from 8 p.m. to 12 p.m., the switch will remain closed. So again it's the same position, so this is the condition of steady state. Okay, so from here what we can conclude, that always at t equal to 0 minus and at t equal to infinity, steady state condition will be there, and at t equal to 0, transient condition will be there. Okay, okay, now see after that, behavior of inductor and capacitor will change. Like see, we'll have three elements mainly. One of the element is resistor, another element is inductor, and another element is capacitor. Resistor is like this, inductor is like this, and capacitor is like this. What is the function of resistor? It opposes the change in current, right? What is the function of inductor? It opposes, sorry, what is the function of inductor? It opposes the flow of current, right? It opposes the flow of current. And what is the property of inductor? And after that, what is the function of capacitor? It opposes the change in voltage. मतलब फॉर एग्जाम्पल एक नॉर्मल लैंग्वेज में समझाती हूँ मैं, इंडक्टर का फंक्शन इज कि इट वॉन्ट अलाउ द चेंज इन करंट, ठीक है, वो करंट को चेंज नहीं होने देता, जितना करंट पहले था उतना ही करंट बाद में होगा. सो फ्रॉम दिस वी कैन कंक्लूड वन फॉर्मूला कि IL ऑफ 0 माइनस वुड बी इक्वल टू IL ऑफ 0 प्लस, कि इंडक्टर में करंट और जितना पहले था उतना ही बाद में होगा, बिकॉज इट इज प्रॉपर्टी ऑफ इंडक्टर दैट इट अपोजेस द चेंज इन फ्लो ऑफ करंट. Similarly, we'll have property of capacitor that it opposes the change in voltage. So that would be VC of 0 minus would be equal to VC of 0 plus. Capacitor won't allow the change in voltage and inductor won't allow the change in current. ठीक है, so basically this formula you need to remember it from the transient purpose. Another thing that you need to remember that in steady state condition, inductor will behave like a short circuit. Short circuit means plain wire. Now why it is so? Because steady state condition में क्या होता है कि बहुत टाइम से सेम करंट फ्लो रहा है. जैसे मैंने बताया कि steady state means कि स्विच की पोजीशन सेम है, तो बहुत टाइम से सेम करंट फ्लो रहा है. तो इफ बहुत टाइम से सेम करंट फ्लो रहा है तो इट विल बिहेव लाइक अ प्लेन वायर ओनली. एंड कैपेसिटर, अगर बहुत टाइम से सेम करंट फ्लो रहा है कैपेसिटर में, देन इट विल गेट फुली चार्ज, और फुली चार्ज होके इट विल बिहेव लाइक अ open circuit. So you just need to remember one thing, that in steady state condition, inductor will behave like a short circuit and capacitor will behave like a open circuit. Just these two things, formula point of view, you need to remember it. Okay, write it down. So now see, this is your assignment question. पहले मैं अपने steps बता रही हूँ, you have to follow those steps. उसके बाद जो assignment के questions है वो बताऊंगी. So in every question of transient response, you have to follow these steps. Step number 1, that is you have to draw circuit at t equal to 0 minus. ये मैं पेपर के पॉइंट ऑफ व्यू से बता रही हूँ, बिकॉज इन पेपर जो तुम्हारा मिड टर्म और एंड टर्म आएगा, यू हैव टू फॉलो ऑल दीज स्टेप्स. ठीक है, असाइनमेंट थोड़ा ये डिफरेंट तरीके से देते हैं एंड पेपर का क्वेश्चन विल बी काइंड ऑफ डिफरेंट. सो आई एम टेलिंग यू अकॉर्डिंग टू द पैटर्न ऑफ पेपर, मिड टर्म एंड एंड टर्म. ओके, so first step is we have to draw the circuit at t equal to 0 minus. As you know, t equal to 0 minus is the condition of steady state, right? It is the condition of steady state, and in the condition of steady state, inductor will behave like a short circuit and capacitor will behave like a open circuit, right? And अगर इंडक्टर है means if there is a question of RL circuit, then in that case you need to calculate IL of 0 minus only. But if there is a question of RC circuit, then in that case you need to calculate VC of 0 minus. अब बच्चे पूछते हैं कि मैम if there is RLC, so RLC is not there in your syllabus, you are having only RL and RC circuit. So how do we get to know? See, in this question they have given you the R, that it is resistor and capacitor. So it is the question of RC circuit. So in this particular question you need to calculate VC of 0 minus. Okay, so this question I'm telling you, like this is the first step. Step number 1, we have to draw circuit at t equal to 0 minus. So see, according to the switch, tell me, at t equal to 0, the switch is closed or opened? Tell me. At t equal to 0, at t equal to 0, see, you have to see it like that. At t equal to 0, it is closed. So just before that, it was opened, right? So it would be opened. And as I told you, in this case, capacitor will behave as a open circuit. So remove capacitor, this will behave as a open circuit. Correct? Mark point A and B terminal, and in this particular set, as I said, you need to calculate VC of 0 minus. Where you need to calculate VC of 0 minus, that would be across points A and B terminal. Basically, you need to calculate VAB, that would be equal to VC of 0 minus. Understood? Now tell me, any doubt up to here? As I told you in the Thevenin theorem, that how will we calculate VAB is similar to the VTH. Like you are standing at A, you need to move towards B. You will move from C to D, E to B, right? A पे खड़े हो, B पे जाना है. Then you will move from A to C, C to D, D to E, and E to B, right? AC, no current is flowing because it's open circuit, 0. CD, no resistance is there and no current is there, 0. DE, as you can say, again it's an open circuit, so no current will flow across 6 ohm as well, 0. VEB, this is also 0 because no resistance, no current. So ultimately we got it as VC of 0 minus is equal to 0 volt. Up to here we have completed our step number 1. Okay, now after that, always step number 2. As I told you, we have to follow these steps only in each and every question. Now we need to draw circuit at t equal to infinity. As I told you, t is equal to infinity is also the steady state condition, and in the steady state condition again capacitor will behave as a open circuit, and we need to calculate over here is VC of infinity. Okay, if at 0 minus, so VC of 0 minus we need to calculate, at infinity we need to calculate VC of infinity. So I'm redrawing the diagram again, like this was the question. So we have to draw the circuit at t equal to infinity. At t equal to 0, the switch is closed, means tell me at t equal to infinity, the switch is opened or closed? The switch is closed, right? So I'm closing the switch. If I'll close this switch, then connection will be formed, right? And again capacitor will behave as a open circuit, mark A and B terminal, and we can conclude that VAB would be equal to VC of infinity. That is what we need to calculate it over here. So VAB, again as I told you, mark C, D, E, B. So VAB would be VAC plus VCD plus VDE plus VEB. Correct? VAC is open circuit, 0. VCD अब यहाँ पे close हो गया, means some of the current is flowing in 6 ohm, right? So let us consider ICD into RCD. VDE, नहीं sorry, DC में कुछ भी नहीं है, that's a open circuit, 0. VDE we can write it down as IDE into RDE. VEB is also 0 because no current is flowing over there. Now RDE means resistance across D to E, that is 6 ohm. IDE is the current flowing across 6 ohm, and that's easily we can get it by mesh analysis. So it would be minus 6I1 plus 12 is equal to 0. So minus 12I1 is equal to minus 12. I1 would be equal to 1 ampere. So IDE means 1 ampere. So ultimately we'll get it as VC of infinity as 6 volt. Finally, our step number 2 is also completed. Okay, after that we need to move towards step number 3. Step number 3, we have to draw circuit at t equal to 0. Okay? Now as you know, t equal to 0 is the transient condition, correct? And transient condition में inductor will remain inductor only and capacitor will remain capacitor only. So now in this particular condition, what we need to calculate, that is tau. What is tau over here? Tau is the time constant, and time constant ka formula is, if there is RC circuit, then the formula is R equivalent multiplied by C. But if there is RL circuit, then the formula for tau is L divided by R equivalent. Okay, and tau is the time, so its unit is in seconds. ठीक है? R equivalent is similar, we can calculate it how, as we have done in the Thevenin, that is RTH. So what we need to calculate RTH or R equivalent, we need to remove all the sources. If you remember Thevenin theorem, voltage source must be short circuit and current source must be open circuit. Okay, now back to the question. This was the question. Now that is step number 3, that we have to draw the circuit at t equal to 0. T equal to 0 is the transient condition, and in the transient condition, inductor will remain inductor, okay, and capacitor will remain capacitor. Now tell me, at t equal to 0, the switch is closed or opened? Closed. Let's redraw the diagram. It is closed. Resistor as it is, resistor as it is, resistor as it is, and capacitor as it is. Correct? Now, what we need to calculate over this, that is tau. Tau formula is R equivalent multiplied by C. Now, for a calculation of R equivalent, we have to redraw the circuit, right? For that, all the sources must be removed. Voltage source must be short circuit and current source must be open circuit. In this case, we don't have any current source, so I'm not using that. Voltage source is there, that is short circuit. Resistor as it is, correct. And यहाँ पे what we need to do, open circuit capacitor also. Capacitor होगा तो open circuit कर देना, and from those terminal only we need to calculate R equivalent. जैसे मैंने बताया था थेवेनिन में हम क्या निकालते थे, RTH, that is equal to RAB, right? Same method. 8, 6, 6. Now again, just imagine that you are standing at A, you need to move towards B. Okay, 6 ohm, 6 ohm, 8 ohm, all these three are your friends. So, जिस friend का घर at the same path, that means they are in series. जिस friend का घर are at the different path, that means they are in parallel. You will start with the resistance which is very far away from you, that is 6 ohm. तो तुम A से चल रहे हो B पे जाना है. टेल मी कि इस 6 ओम या इस 6 ओम का घर एक ही रास्ते पे आ रहा है या अलग अलग रास्ते पे आ रहा है? दोनों से एक साथ मिलके आ सकते हो या अलग अलग रास्ते पे जाना पड़ेगा? सी मूव फ्रॉम ए, यहाँ पे गए. अब इससे मिलना है तो यू नीड टू चूज द लॉन्गर पाथ. इससे मिलना है तो शॉर्टेस्ट में चल जाएगा. दैट मीन्स यू, that is at the different path. Different path means both are connected in parallel. So 6 parallel 6, right? This is suppose 8 ohm. Again do the same procedure. Don't take shortcut. Okay, shortcut करोगे गलती करोगे. Again stand at A, move towards B. Now इसका घर और इसका घर, they are at the same path or at the different path? चलो दोनों से मिलके आ सकते हो? Both of them are in series. So 6 parallel 6 is 3. 8 plus 3 is 11. So from this we'll get the value of R equivalent is 11 ohm. Okay, and capacitor value they have already given, that is 1 millifarad, 1 into 10 raised to power minus 3. So ultimately we get it as 11 into 10 raised to power minus 3 seconds. This is the value of time constant, we got it, and this is what we need to calculate it over in the step number 3. Okay, clear? Now After this, step number 3 is also done. We need to calculate the last and final step, step number 4. So what we need to calculate VC of T if there is a case of capacitor. If there is a case of inductor means RL circuit, then in that case we need to calculate IL of T. Okay, so this is the case of capacitor. So VC of T is equal to, we'll have formula VC of infinity plus VC of 0 minus VC of infinity e raised to power minus t by tau. This formula is also given in your handbook, but उन्होंने ये वाला formula नहीं दिया हुआ. By my method they have given different formula, so don't rely on handbook. This formula you need to remember it. Okay. Yeah, so I'm directly preparing you for the GATE exam. Okay, anyways, this is the easy formula. ठीक है, उस पे जाओगे तो you need to follow different steps. Don't follow that. This would be the easy method for you. Okay, transient को solve करने के there are a lot of methods. I told you and summarize all these steps in a very easy way so that you'll never forget this. So for IL of T निकालना है तो IL of infinity, IL of 0 minus IL of infinity e raised to power minus t by tau. Okay, VC of infinity we have already calculated. How much? 6 volt. Put it 6 volt. VC of 0 minus also we have already calculated, 0 volt. Put it 0 volt minus 6 again, and then e raised to power minus t by tau. Tau is how much? 0.11 second. ठीक है, तो इसको हम सॉल्व करेंगे. व्हाट विल गेट 6 minus 6 into e raised to power minus t by 0.11. यही आ रहा था ना. And then we can take, okay sorry, it's 0.011. तो इसको ऐसे सॉल्व कर लेना. 1 by 0.011 is how much? Do it in your calculator. तो that would be, बताओ क्या आ रहा है? 9019 90.90 t. Okay, 6 we can take it to a common, then it would be e raised to power minus 90.90 t. This is the final value of VC of t. ठीक है. Now the question is कि ma'am, if suppose they have given is RC circuit, but instead of asking voltage, they can ask current. If they'll ask current, then what we need to do? Then तो I told you कि हाँ, RC सर्किट है तो हमेशा वोल्टेज ही निकलेगा, RL सर्किट है तो करंट ही निकलेगा. बट अगर उन्होंने अपोजिट पूछ लिया, लाइक इन RC सर्किट they'll ask you the current IC, so you need to apply formula IC is equal to C dV by dt. Whatever the value of V, you will get it, substitute it here. But in RL circuit, if they'll ask you the voltage, then voltage across inductor formula is L di by dt. Okay, now your assignment question. Okay, now they have given you कि x की value ये है, then the time constant for the circuit is millisecond. As I told you, time constant is what? Tau, and that is R equivalent multiplied by C. So I told you कि R equivalent C कैसे निकलता है, RTH कैसे निकलता है? By my values. Means यहाँ पे इन्होंने क्या दिया हुआ है, x की value 4.90 है, तो जहां जहां मैंने 8 लिया है, here you can take 4.90 value, 8 को replace कर देना 4.90 से, then accordingly you will get the value for 2. Okay, now next question, they said if x is this, then the magnitude of steady state value of the voltage across capacitor is dash volts. Assume the capacitor is initially relaxed. इसका मतलब क्या है? Assume the capacitor is initially relaxed का मतलब कि VC of 0 minus would be equal to 0. ठीक है, वन मोर थिंग, whenever they say कि इनिशियल कंडीशन है या इनिशियली, तो उसका मतलब होगा अगर इंडक्टर का केस है तो IL ऑफ 0 माइनस, एंड वोल्टेज का कैपेसिटर का केस हो तो VC ऑफ 0 माइनस. तो इनिशियली रिलैक्स्ड मीन्स VC ऑफ 0 माइनस they have given 0, right? तो मैग्नीट्यूड ऑफ द स्टेडी स्टेट वैल्यू, स्टेडी स्टेट वैल्यू कौन सी हो गई? VC ऑफ 0 माइनस, तो इन्होंने बोल दी 0. स्टेडी स्टेट आई टोल्ड यू दो ही कंडीशन होती है, या तो t इक्वल टू 0 पे होती है या फिर t इक्वल टू इन्फिनिटी पे होती है. तो इनडायरेक्टली दे आर आस्किंग द VC ऑफ इन्फिनिटी. ठीक है, VC ऑफ इन्फिनिटी भी हमने निकाल लिया. जहाँ पे भी हमने निकाला था दिस इज VC ऑफ इन्फिनिटी, मैंने जहाँ पे 8 लिया था, तुम्हें क्या लेना है? 8.80 ohms. Okay, now in the third question they ask you if X is this and the initial voltage across the capacitor is 10 volt, means VC of 0 minus कितना दिया हुआ है इस पर्टिकुलर कंडीशन के लिए, 15th क्वेश्चन के लिए 10 वोल्ट. जो हमने निकाला था वो मत लेना, अब इन्होंने दे दिया कि VC of 0 minus is 10 volt, then the magnitude of the voltage across the capacitor. तो हमें किसका निकालना है? VC of t की वैल्यू निकालनी है पूरी इक्वेशन के अकॉर्डिंग. लास्ट वाली इक्वेशन जो मैंने ये वाली इक्वेशन निकाली है ग्रीन वाली, ठीक है, पूरा सॉल्व करना है. VC of 0 minus VC of infinity, एंड इन्होंने बोला हुआ है 0.5 टाइम कांस्टेंट, तो इन्होंने टो की वैल्यू भी दे दी खुद से 0.5. तो जो जो इन्होंने वैल्यूज दी है वो तो यही यूज करनी है, और जो जो नहीं दी है वो तुम्हें कैलकुलेट करनी है, और लास्ट में फुल एंड फाइनल आंसर निकालना है. समझ गए? टो दे दिया, VC ऑफ 0 माइनस दे दिया, तो उसके अकॉर्डिंग तुम्हें VC ऑफ t की वैल्यू निकाल. नाउ सी योर नेक्स्ट क्वेश्चन. Step number 1, that we have to draw circuit at t equal to 0 minus, and this is the case of inductor, so we need to calculate IL of 0 minus. Okay, so at t equal to 0 the switch is opened, means just before that switch was closed or opened? Closed, because at t equal to 0 switch is open, means just before that it would be closed. Okay, and inductor will behave as a short circuit, because as I told you this is the steady state condition, and wherever the inductor was there, here we'll need to mark IL of 0 minus. Okay, so now we need to calculate IL of 0 minus, that you can do it by simple using mesh analysis. Okay, this is suppose I1 and this is suppose I2. You can solve it. So IL of 0 minus would be equal to I1 minus I2. या तो mesh से कर लो या फिर direct कर लो. Current यहाँ से move करा, then current is having two option. One is resistance, one is plane path. So current will always follow the plane path, right? So I is equal to V by R. So IL of 0 minus would be equal to V by R. V is how much? 2 volt. Resistance is how much? 1 ohm. तो current is how much? 2 ampere. तो यहाँ से 2 ampere, क्योंकि ऊपर से तो जा ही नहीं रहा है current, right? So IL of 0 minus is 2 ampere. Got it? Now step number 2, we have to draw the circuit at t equal to infinity. So at t equal to 0, the switch is opened or closed? At t equal to 0, it's opened. So t equal to infinity is also opened. And inductor will behave again as short circuit, and here the current would be IL of infinity. So we need to calculate IL of infinity, that would be equal to 0 ampere. As you can see, it's an open circuit, so no current will flow over there. So finally and easily we'll get it as IL of infinity 0 ampere. Yes. So step number 3, we need to draw circuit at t equal to 0, and we need to calculate in this tau. Tau is how much? That is L divided by R equivalent. So at t equal to 0, the switch is opened, right? For calculation of R equivalent, voltage source must be short circuit. Okay, I'm short circuiting the voltage source, and inductor must be open circuit, right? Inductor must be open circuit and mark A and B terminal. As I told you earlier, you are standing at A, you need to move towards B. A and then B. Can you go and meet one of your friend? ए पे खड़े हो, बी पे जाना है, बताओ 1 ओम से मिलने जा सकते हो? दो फ्रेंड है, एक 2 ओम है और एक 1 ओम है, ये तो ओपन सर्किट है, यहाँ जाओगे तो मर जाओगे, आगे रास्ता नहीं है जाने का. सो यू कैन ओनली मीट 2 ओम. सो इन दिस केस आर इक्विवेलेंट इज ओनली 2. सो टो इज इक्वल टू एल डिवाइडेड बाय आर इक्विवेलेंट. तो आर इक्विवेलेंट इज टो. एल की वैल्यू कितनी थी? वी हैव कंसिडर हाउ मच? एल वी हैव कंसिडर 6 हेनरी. तो 6 by 2, that is 3 seconds. ठीक है? Now in the last and the final step, what would be the value? करंट का क्या फॉर्मूला होता है? IL of t IL of infinity plus IL of 0 minus IL of infinity e raised to power minus t by tau. So IL of infinity we have already calculated. IL of 0 minus 2 था. IL of infinity is 0. तो 0 plus 2 minus 0 e raised to power minus t by 3. So 2 into e raised to power minus t by 3 ampere. This is the answer.